Hi, welcome to Principal AI's YouTube channel. On our channel, we cover various kind of system design problems and often AI specific problems. We try to give you the basics of how to approach a system design problem and solve it, which factors to consider, and help you become a better engineer and also help you crack your next system design interview. If you like our YouTube channel, please subscribe and like our videos and leave a comment. It's extremely helpful for us. We also have a newsletter where we publish a lot of free content and articles, and it's also a great way for you to approach us or ask us any questions. Um, Having said that, we'll talk about today's problem, and this is about designing an authentication system. One of our viewers asked us to solve these problems, and that is the reason why we are taking it up. Um, so let's look at what the actual problem statement is. So the problem statement is about designing a centralized authentication system for a very large company with millions of users. We are asked only to design an authentication system and not an authorization system. This is an important point because these two things go hand in hand, and any software designer, software engineer is expected to know what an authorization system is and what an authentication system is. So we'll see that in the next slide. But we are also told that we need to support a legacy authentication tool such as LDAP. You can think of LDAP as pretty much as a database of sort that provides identity where users can create their passwords, change their passwords, and so on. So we are told that our new system must support such old legacy authentication mechanisms as well. Now, let us understand what authentication is. Authentication is the process of verifying the identity of an entity. So often, a user has to log in into their email service, for example. They have to provide their email and password. And this password is actually helping the system verify that the user is actually who they claim to be. Now, normally authentication is for users, but it can also be for devices and servers and so on. So it's basically a very simple process where the entity willing to communicate with your system identifies itself by providing some information that you have exchanged earlier through a secret process, such as password they created during a sign-up process or a private key that was or a private public key that was exchanged earlier. So this is a very critical security measure that helps to protect systems and data from unauthorized access, and a very well known and a widely used thing. And any good software engineer must know what authentication uh, is. So in any system design interview, always make sure that you ask a lot of questions to that interviewer. And when you're presented a problem, instead of rushing in, take some time to absorb the problem, understand it, figure out what the gaps are, the information that's highlighted in the problem statement, and the gaps in the problem statement, and make sure that you ask questions to establish the scope of the problem before you rush into solving it. And I like to give a structure to these questions, always establish the context of the problem first, ask questions like who are we building the system for? Why are we building it? What expect currency exits? Are we building on top of that, or are we building something from scratch? Once you establish the context, move on to ask more requirement specific questions. Sometimes this might appear very basic or obvious, but nothing is obvious. Always make sure you ask and clarify. For example, what kind of authentication are we looking at? Is this username password? Is it email password? Are we going to support things like magic links and OTPs? Or do we need to support such two-factor authentication and so on? So once you establish the requirements, move on to the scale. Ask questions like how many users are we going to support? Millions of users or thousands of users? What about new users? Are we going to delete old users? Is this a global system that requires more distributed databases and so on, or is it more a centralized thing? Are we building it for consumers in a sense, any end of user, or is for a specific organization and their employees, and so on? Um, so context, requirements, and scale. Once you establish these three things, only then you can move on to the next problem. Once you are done asking question, the next step is to actually enumerate the functional requirements. It again, it might seem very obvious and basic, but you still need to do it. Um, don't treat anything as too obvious. Just write it down, because the interviewer might sometimes think that you don't know some basic thing which you thought was obvious. So in this requirements, the user is going to log in from a form on a web page, which they provide their email and password. The identity management of the user will be in the database, so the actual username and password or hash password will be stored in a database. We need to support two-factor authentication with an X-based OTP for now, but it should be extendable to any other form of challenges. It should be possible to suspend users. And how do we verify user is authenticated? It will be them using JWT, that is JSON Web Tokens. Now, if you don't know what JSON Web Tokens is, I can tell you in very short. Summary, it's basically a JSON object which contains some information, and it's signed using asymmetric cryptography. It's signed by the server and provided to the user, where the user authenticate themselves. So any time an user presents this JWT to the server can verify their signature and make sure that this is a valid JWT. And as long as a valid JWT, the server trusts the party that provides this JWT. Now, this also opens up possibilities for session hijacking, where a malicious person might somehow get access to this JWT, but we won't be talking about that here. Um, there are other ways of verifying authentication, such as a session cookie and um, some kind of session IB that server maintains on their side. But just JSON Web Tokens are becoming industry standard these days, so we'll go with that. Then also users should be able to log in from multiple devices. All sessions must expire after 24 hours, but for mobile devices, it would be 7 days. So the JSON Web Tokens issued for mobile devices will have an expiry of around 7 days, but for everything else, it would be 24 hours. You also need to support signups, that is the process of creating the new user. Um, Once we are done with functional requirements, we move on to non-functional requirements. We are told that there are 10 million active users, and there are around 10,000 signups per day and 1 million logins per day. That's daily active users. However, there are around 100 million requests to check if a GWT token is valid. So you can see almost 1:100 ratio here. So it's a very read heavy system, and the verification call to GWT is much, much higher scale than the logging process. And also, we need to support all the industry best security practices about encryption, encrypting data in flight, etc. Uh, so if you don't know what those practices are, don't worry right now, we'll call them later. Once we have understood the non-functional requirements, we always move to the high-level design. The objective of high-level design is to demonstrate to your interviewer what are going to be the basic components and how they are going to play with each other in your design. This is a good way to show the interviewer that you have understood the problem well. In case you have not, they'll probably give you some hints to correct yourself. So uh, here is the high-level design that I would propose. That is, we have an API gateway, which basically is um, first line of defense between our systems and rest of the world. So what mobile devices, browsers, etc. would talk to the API gateway. API gateway provides us basic features such as load balancing, uh, distributed the load across the geographic regions, BDOS protection, and so on. The API gateway then talks to what we call the backend for front-end servers. This is basically the service that's responsible for translating the internal objects or data models into a REST format. Um, Sometimes I prefer to design the microservices using gRPC, Google RPCs, and use the consumer interface as REST, as in JSON. So this basically does the job of translating protobufs into JSON objects. Again, backend profiler service are pretty much stateless workers that just translate protos to JSON and so on. And and then the two major components we have is the auth service and the sign up service. The sign up service is basically supports just clear operations on our identity database. Our identity database could be a relational database that stores all the user identity information, or could be an AVDAT and so on. And the sign up service is responsible for creating new records in them. The auth service, on the other hand, is responsible for handling things such as login and logout operations, and it talks to what we call a crypto service. And how do we verify the user's authentication? We already decided that we are going to use JSON Web Tokens, and JSON Web Tokens will have two operations: signing and verification of existing signature. So these two operations are supported by crypto service. The reason why they have a separate crypto service from auth service is because cryptographic operations include using private keys, which should be kept secret, rotated on family basis, and we don't want all the components in our organization having access to private keys. So anything that involves a private key, that application is can be moved to a separate service and a separate team to manage it, so they can be kept secret. And best practices around security can be followed. Audit logs are another important component. This is responsible for logging all the events that are happening in the system, so that they can be processed later and can be stored in CI data house for querying. So this is a very high level design, but a few additional components that we'll discuss later, which are not present in this diagram, but this is a good high level design to propose to your interviewer and get some buy-in from them. So once we have done all these methods, the next step we go for is describing some of the internal details. Remember, setting passwords is an important point. You might think it's obvious if you are experienced, but password should never be saved in plain text. The best practice prompt is typically is KB salt. It's a unique string per user. A bank that use salt to user's password and then hash it and store that hash. The purpose of the sort is basically to make sure if two users have same passwords, the hash for them won't be the same. So this is just a best practice, and it's helpful to let you know that you know about this best practice, even though it might sound very obvious to you. Now, looking at our system, we already know that the verify endpoint is going to be the most important one and most scored one. We know that it'll get this around 100 million requests per day, which is frankly quite a lot. Typical verification involves taking a GWP and using a public key to actually verify the signature that's mentioned in the JSON Web Token. This is a cryptographic operation, and all cryptographic operations typically are compute heavy. So we don't want to like waste a lot of time doing this. So one way to simplify this is once the JSON Web Token is created, best store it in a in-memory cache. And we know that number of daily active users is close to 1 million. So maybe we might want to store 4 or 5 million active JSON Web tokens in the in-memory cache. This in-memory cache should also have some validation based on time. So because we don't have to store an expired JSON web token in that memory, so it needs to be purged out of storage as soon as it becomes invalid. So we can use an off-the-shelf product like Redis to do this. And if there is a cache miss, the request will go to crypto service, which will do the actual verification of JSON web token, and it will write the valid JSON lab token to the invalid cache so that subsequent requests can be handled way faster. Now, JSON web tokens can't really be invalidated because they always become expired at a specified time, and until then, they're always valid unless we change the pirate key itself. So one way to solve this problem is by creating a unique salt for the user and then using their salt in JSON web token. So next time when we want to somehow make the existing JSON web tokens invalid, we can just change the salt in the database. So the JSON web token verification would fail because the salt has changed. Here, yeah, we'll look into those details in the next couple of slides. Um, so invalidate basically means a logout operation, and this is on the important operation. So invalidate can be called either for a specific JSON web token, or it might be called for a user itself, so that all the user sessions across all devices be invalidated. Uh, if it's a device specific invalidate, then it's basically the client can just delete the JSON web token it has, and as a result, the client simply won't be able to authenticate itself again. That's the simplest way. But if you want to invalidate across the user's devices, then we can basically change the JSON web token sort that I earlier alluded to, and then also clear this cache from the in-memory storage so that the next verification call will find a cache miss and we'll end up ripping the crypto service, which will compute a name JSON web token. Then the validation will fail if the verify method provides an old JSON web token. So this basically just involves the invalidate method basically involves just clearing the cache and updating the salt in the identity BB. So after invalidate, let's look at the sign-in method. Sign-in method, we are told that will be around 1 million silence per day. So this is a relatively low traffic compared to our verify endpoint. Um, we already discussed a bit in the high level design, but there are some additional details here. Look at the risk engine. So nowadays, even if the user is duly giving you the right password, we also do some extra checks to make sure their password is not hacked and so on. So typically most modern systems will have some sort of risk engine. So once the auth service has verified that user has given the right password, they will also do a risk scanning check where by looking at various signals such as the user's geo, IP address, the device, and so on. The user might be asked to go through a challenge, which is typically an OTP, or if the two-factor authentication is enabled, then the user will always be asked to produce OTP. So this is the risk engine that does this job. It is typically a machine learning kind of a system where there will be models that are trained on different kind of input output behavior, and once the risk checks have passed, our service will talk to crypto service to produce a signed GWP, which will be returned back to the client. The audit log again is the message queue where all the logs from auth service and signed up service are be returned to. This can be put into a data warehouse for queries, anomaly detections, and so on. We have also displayed a notification queue here. This is again a message queue. So auth service, whenever it wants to send any kind of notification to the user, which is meant for OTPs or email notification, fraud alerts, and so on, until like it'll enter notification queue, and there will be rest of the system here that's responsible for delivering those notifications based on what is the channel of notification. It should be a text message, email, and so on. So we have done a whole video on how notifications work in such systems. So if you are interested, you can always have a look at that video. But for the purpose of this interview, we won't go into the details of how notifications are actually handled. Uh, so having said that, let's look at how the whole thing works together. What we'll do is this is a typical user journey, and we show how different operations will happen in that sequence. The first step is typically user signing up by calling the sign up service, and sign up service basically writes to the storage, creates a new record. Once the sign up is successful, user may log in by providing the email and password. When auth service reads the user's password from storage, compares the hash, and if things are fine, it would issue a JWT. But if there is a two-factor authentication enabled, then it will throw a challenge. And when the challenge is so easily expected to complete that challenge by entering an OPP and so on, and call a complete challenge method or not service. And once this is successful, the use auth service will get per GWP from cache, or if there is a cache miss, it will be obtained from the crypto service. And then that GWP will be returned to the user. That is the coin device which can be used for subsequent calls. So this is how the whole picture looks like. And in conclusion, we can say that um, there are many other things that need to happen as part of the system. One is rate limiting. We don't want users to try different passwords. If there are multiple attempts, he might want to throw a captcha like challenge for the user. So these things can be done at the API gateway layer. If not captcha, at least the rate limiting can be done at the API gateway layer. Most of the modern cloud service providers give you these API gateways off the shelf that can do a lot of these things for you. Um, Also remember that it's not just the user devices that are going to authenticate themselves, it's also other microservices in the system, because the client might call this microservices directly with the JWT token. So they have to call the authentication service to verify that JWT token. This is something that I think we missed showing in the diagram, but worth mentioning. The other Another thing to remember here is that data must be encrypted in transit, which can be achieved using a TLS. It's a transport level security, which is a newer version of the old SSL protocol. This uses asymmetric cryptography to make sure that data in transit cannot be read by any other system than the intended recipient. The TLSs will typically be used between the client devices and the API gateway. This is another advantage of using API Gateway, as it handles TLS collections for us. Um, the identity provider in powered system design is storage, but this can also be any legacy system such as LDAP, or even like multiple systems. We can always create an abstraction on top of the existing legacy systems. All we need from these legacy systems is ability to get their password, get the user's password and match it, because that's the only reason why we are using this identity storage. Everything else is handled by our authentication service and a crypto service. So these are our concluding remarks for this video, and we have kept the design really simple. And because it's just authentication, that makes our job very simple. But if we have to extend this design to also provide authorization, then this gets slightly more complicated, as we have to talk about user roles and grants and ACOs and ACOs for different microservices and so on, which will make it really very complicated. But authentication is relatively simpler. So if you like this video, and if you have any further questions or even criticism, please feel free to leave a comment on this video, and that helps us improve our videos and their presentation better. If you have seen any other better ways of solving the same problem, please provide us links, and do subscribe to our channel to show your support. We also have a blog and a newsletter, the links for which are present in the video description. Please feel free to subscribe to them to stay up to date with our latest posts and videos. We also cover AI specific problems, so that is something also you might want to look at on our channel. Thanks. Thank you for your time.